Hello, everyone. My name is Mia Carberry, and I'm here to introduce the climate problem to you, my community. Here in North Carolina, we are blessed with a variety of environments. We have the beach, the mountains, and a lot of land for farming. Keep this in mind during this presentation. Throughout this presentation, I will discuss quite a few topics. These topics will address the following. What is climate change? What is climate? The history of climate, our present climate. What is forcing climate change? What are the feedback loops contributing to climate change? How it is and will impact us physically and socioeconomically. What we can do to mitigate climate change. The future outlook for our state. And finally, I will summarize what all of this means for our community. Firstly, let me explain what climate is. The definition of climate is the varying aspects of atmosphere over time. Examples of aspects of climate include the average humidity of a region, the average type of precipitation of a region, and the average temperature of a region, and more. Therefore, climate change would be any systemic change in the long-term statistics of climate. In the past, we have had quite a few climate shifts. Earth's climate has had multiple dramatic changes that have had severe consequences for organisms and their ecosystems. For example, around 2 billion years ago, photosynthetic organisms' populations grew and they consumed more CO2. This reduction of greenhouse gases is what scientists believe caused the population's temperature to drop and the Huronian ice ages to begin. These ice ages were interrupted by warm periods, but the ice ages were so extreme that glaciers reached near the equator. On the other extreme, 55 million years ago, volcanic eruptions caused a massive increase in greenhouse gases in the atmosphere that scientists believe caused the Permian Eocene thermal maximum, which was 100,000 years of warming by between 5 and 8 degrees Celsius. Warming oceans caused the extinction of a large portion of marine life. Scientists have studied these shifts by examining proxies like ice cores, ocean sediments, and tree rings, which have preserved evidence of past climate events. The climate change occurring now is different. It is caused by human activities. The difference between modern climate change and climate change in the past is that today's climate change is being heavily influenced by human activities. The planet maintains an energy balance of energy entering our atmosphere and leaving our atmosphere. Humans are throwing off that energy balance with the use of their fossil fuels, deforestation, and aerosols. As you can see in this graph, warming has been occurring in North Dakota over the last 100 years. It is important to mention that even small changes in temperature can have severe consequences. You can also see similar temperature increases in Texas and Austria in the last 100 years as well, which provides evidence towards global temperature shifts. One of the biggest ways humans contribute to climate change is by emitting fossil fuels like carbon dioxide, methane, and halocarbons. Carbon has a natural cycle that is being perturbed by human activities. The burning of fossil fuels is releasing carbon into the atmosphere at a much faster rate than would naturally occur with the carbon cycle. North Carolina is in the top 10 for states amounts of manufacturing companies. The carbon we emit now will affect our biosphere for tens of thousands of years. Another fossil fuel humans release is methane. Methane is 32 times more powerful than CO2 when it comes to climate change. Two large ways we emit methane are in agriculture, in our cattle farms, and in landfill processes. Here in North Carolina, pig farms are scattered across the state. The final fossil fuel I will discuss is halocarbons. Halocarbons are 100% man-made greenhouse gases that are up to 1,000 times more powerful than carbon. Pesticides, plastics, and refrigerants are all examples of halocarbons. Halocarbons also destroy the ozone layer and allow more solar energy to enter our atmosphere. Speaking of solar energy, the sun is another forcing agent of climate change. Firstly, the sun didn't used to be so powerful. In fact, it was about 70% dimmer. Additionally, the orbit around the sun differs between circular and elliptical every 100,000 years, which you can see in the background image. This results in a difference in the incoming solar energy depending on how close the Earth is to the sun. Now I'll shift my focus to feedback loops. Feedback loops are consequences of warming that amplify or diminish the warming. They do not cause the warming. Positive feedback loops amplify or add to the warming that has occurred, and negative feedback loops diminish or subtract from the warming that has occurred. An example of a positive feedback loop is the ice albedo feedback loop. Albedo is the proportion of light or radiation that is reflected by a surface. Ice has a very high albedo, reflecting up to 70% of light back up into the atmosphere. In this feedback loop, warming causes ice to melt, which leads to a decrease in the albedo of a planet. That means that less energy is being reflected out of the atmosphere, and that amplifies the warming, which causes more ice to melt, and on and on and on. The point is, positive feedback loops like this one amplify warming. An example of a negative feedback loop is cloud feedback. In cloud feedback, it depends on the type of clouds in the atmosphere. Cirrus clouds are high and thin. They have a low albedo and reflect heat back towards the surface. They hold heat into the planet. Cumulus clouds are low and thick. They have a high albedo and reflect incoming energy back out into the atmosphere. Scientists have determined that overall, clouds reflect more energy than they absorb. Climate is impacting many aspects of the planet and lives on it. For example, our oceans. The warming of our planet is affecting the oceans in many different ways. Firstly, sea level rise due to melting ice is going to impact many sea creatures. It will also threaten our coastal property and infrastructure. Additionally, the warming of the ocean is going to cause the water to expand, causing more sea level rise. Secondly, freshwater glaciers and ice sheets will melt due to the warming and mix with saltwater oceans. This will cause ocean currents to shift, affecting global temperatures and ocean food chains. Finally, the warming trend will lead to ocean acidification, which we will talk about in the next slide, along with its socioeconomic impacts. Ocean acidification is a 100% guaranteed consequence of modern climate change. Ocean acidification occurs when the ocean absorbs carbon dioxide from the atmosphere and converts it into carbonic acid. This slowly makes the ocean more acidic over time. This acidity creates conditions that eat away at the shells of marine creatures like clams, crabs, lobsters, and our coral reefs. Our coral reefs are extremely diverse and important ecosystems that provide habitats to many creatures. The consequences of ocean acidification will lead to weakened food security and massive job losses in the fishing industry. Globally, about 1 million people rely on the ocean for a source of protein. It is important to note that ocean acidification has happened in the past and it has resulted in mass extinctions. This is not just a theory. Another area we would see consequences from climate change is in our agriculture, which is a large contributor to the economy in North Carolina and in the country as a whole. Agriculture is an enormous part of the US economy, contributing roughly 1.3 trillion to the GDP in 2021. In North Carolina alone, we recently contributed $100 billion from our agriculture, which is North Carolina's #1 industry. According to a local news station, Spectrum News, 20% of the state's workforce is currently tied up in agriculture. Now, the problem is that agriculture relies on climate factors like soil moisture, humidity, soil nutrient levels, water availability, temperature, frequency of extreme weather, atmospheric CO2, and more. As you can see, it's very complicated. With modern climate change, it is likely that these factors will shift, changing the way we grow crops, raise cattle, and operate fisheries. The consequences of these changes could result in food shortages, food disruptions, increases in the prices of goods, and damages to the economy. It would be costly to adapt to the changes it, of climate on the agriculture. Action now towards climate mitigation is very important. The centerpiece of mitigation has to be rising the price of emissions. Right now, it is essentially free for emitters to emit greenhouse gases into the atmosphere, and society is bearing the cost of the damages. It is time that we hold emitters accountable for their emissions. There are two options to rising the cost of emissions. Firstly, we can tax emissions. Secondly, we can require emitters to buy permits allowing a certain amount of emissions per permit. It would make sense that the revenue from either of these options be placed back into cleaner technology and to protect our most vulnerable communities. These systems are effective in other countries. For example, the European Union operates on a cap and trade system, and Sweden set a carbon tax of $127 per ton of carbon and have reduced emissions by 25% since 1995. In the carbon tax, makers set tax rates and adjust it over time, and the uncertainty lies in the amount of emissions. While in the cap and trade system, policymakers set a total amount of permits used per year, and the uncertainty lies in the total cost. Afforestation, or planting trees, is a very effective geoengineering technique used to reduce carbon dioxide in the atmosphere. If 25% more global tree coverage was achieved, it could reduce atmospheric carbon dioxide by 25% and help mitigate greenhouse gases, which cause warming. Planting trees in bearing areas has the most effective effect on carbon dioxide levels. Planting trees also helps with soil erosion, which will occur more with higher temperatures and drier grounds. So plant trees. Right now, North Carolina is becoming warmer, wetter, and more humid. In the future, we are expected to face temperature increases, sea level rise, ocean acidification, and the agricultural impacts of climate change. We can expect temperature increases of 6 to 10 degrees Celsius by 2100 if no action is taken to reduce emissions. We will be impacted economically, physically, and socially as hurricanes strengthen, sea level rises, and our coasts are severely damaged. Additionally, the future heat index poses a public health risk. In summary, North Carolina will be heavily affected by climate change due to having a large farming culture in rural areas and being located on the coast. Ocean impacts like sea level rise and ocean acidification will cause costly damages to coastal regions and a reduction in jobs in the fishing industry. It will also result in food insecurity. Hurricanes will strengthen and result in more damages during storms. Sea level rise will also allow hurricanes to move deeper into the state with more strength. Storm surges will be very severe. Heating and cooling will cost us money just to heat and cool our house, and heat will also cost us money in working hours, crops, lives, and electricity. Actions like switching to green energy, putting a price on carbon, recycling, and afforestation are important to mitigate climate change. We need to start action now, and we need to make putting a price on emissions our centerpiece. These are my references, and thank you guys for listening.